Ulukut Illunnasi. Welcome to Music Code, the show where we explore a topic in computer science, a topic in music, and combine them in creative ways. In this fifth episode, we will explore repeats and loops. Repeats. Repetition is an important part of music, and it comes in different flavors, such as repeating notes, lyrics, or full sections. In Western notation, we have specific symbols that indicate what parts we have to repeat, and this saves us from having to write the same notes over and over again. Nowadays, that isn't such a big deal because we have copy-paste. But before we had computers, people had to write these notes by hand. There are a number of symbols to indicate repetitions, and I'll go over the main ones in this episode. To make things a bit easier, I'll be using a melody that most of us should know, Twinkle Twinkle. The first symbol we'll look at is the standard repeat symbol, which typically comes in pairs. The way it works is that as you're reading the notes, when you reach the right repeat symbol, you don't continue reading the notes that come right after it. Instead, you jump back to the left repeat symbol and start from there. If there is no left repeat symbol, that means that you're meant to jump back to the beginning of the piece. If you want to repeat a section more than once, you can do so by adding a number above the right-hand repeat symbol. If you want to get fancier, you can add what are called volta brackets, which allow you to specify different endings based on the number of repeats you're doing. Another useful symbol is the da capo symbol. Da capo means from the beginning in Italian. So when you see the symbol, you jump all the way back to the beginning and start from there. A slight variant of this is the dal segno indicator. Dal segno is Italian for from the symbol. So when you see this, you don't jump to the beginning of the piece. Instead, you jump to this weird S-looking symbol and start from there. The last symbol we'll review is the coda symbol. When you see this, you're meant to jump forward to the next instance of the coda symbol, skipping all the bars in between. The coda symbol doesn't usually appear on its own. It typically comes coupled with the dal segno or the da capo segno. When you use a coda with da capo or dal segno, you indicate it with da capo al coda or dal segno al coda. Let's listen to our final example, which makes use of all the repeats we've covered. These repeat symbols help us not only avoid writing out tedious repetitions in a score, but also reduces the number of pages, which is good for the musicians performing the music. In computer science, we also have a way of specifying when things should be repeated, and they're called loops. If you've ever seen The Simpsons, you'll remember that in the introduction, Bart was always writing something on the chalkboard multiple times. This was meant to be punishment for doing the thing he was writing about, since writing something over and over is really tedious. On a computer, it wouldn't be so bad because we could just do copy-paste, but it would still be kind of annoying. Let's say your grandmother was turning 100 and you wanted to send her an email with 100 happy birthday messages. Of course, you could write it once, hit copy, and then hit paste 99 times. But let's say you wanted to change the 50th message to say halfway there. you would have to count down 50 lines to make sure you were changing the correct one. An easier way to do this would be to use for loops. Here's what it would look like in C++. But now let's decompose this a little bit. For loops typically have a counter variable that keep track of how many times you've run the code. The first line of a for loop typically has 3 components. The first part defines the counter variable. Remember, we typically use zero-based numbering, as discussed in episode 2. The second defines the boundary condition, or when we should exit the loop. In this case, we should exit the loop when I is greater than 100. The third part indicates how we should change the counter at the end of each pass. In this example, we're simply adding 1 to the counter variable I. Inside the for loop, we specify the code that we want run multiple times. In this example, it simply prints "Happy birthday, Grandma." Hooray! When we run this code, it'll print that message 100 times. But remember that we wanted to print a different message halfway through? Well, the inside of for loops don't just have to be one line. They can be as many lines as we want. So we can modify this code to check when I is equal to 49, remember that we're in zero-based numbering, and print halfway there. As I just mentioned, inside a for loop you can put all sorts of code, including other for loops. So let's say that instead of sending 100 happy birthday messages to Grandma, we wanted to send her 100 lines of candle emojis, where each line had an increasing number of candles. We can do this with nested for loops. In this example, every time the outer for loop runs, the inner for loop will run, and it will run for a number of times equal to the outer loop's counter. Let's see it in action. An equivalent type of loop is a while loop. The first line of a while loop only specifies the boundary condition, so you have to make sure that you're updating your counter variable somewhere else, otherwise it can cause problems. For example, take this simple while loop. Can you spot the problem with it? The problem is that we never update the counter variable, which means it will always stay equal to 0, which means we will never meet the boundary condition, which means we will never exit the while loop. In other words, this while loop will run forever. This is what we'd call an infinite loop. It sounds cool, but it's actually very problematic and can sometimes even cause your whole computer to crash. It's a very common software bug, so us programmers have to be careful about it. Before going to the final section of this episode, I'd like to thank my friend Kevin Ablutsiak for helping me with the Inuktitut language. Both musical repeats and programming loops allow us to express complex structures in a more compact way than if we were to write them out explicitly. For the final performance section of this episode, I'm going to be riffing on this idea, where I'll be using both musical repeats and programming loops. Enjoy. you.